Hey everyone, welcome back to BigBrains Chip. Today we are solving container with most water, a classic two-pointer problem. The question looks simple, but there is one important observation that takes us from the brute force to an O of n solution. Each number represents the height of a vertical line. We need to choose two lines that can hold the maximum amount of water between them. The amount of water depends on two things: the distance between the lines and the height of the shorter line. But if the question comes like, why the shorter line? Because water can't rise above the shorter wall. Even if the other wall is much taller, the shorter wall is where the water will overflow. The obvious solution is to try every possible pair of lines, and for every pair we calculate the area and keep the maximum. But there are roughly n square pairs, so the time complexity is O of n square. But we can make it even better. Instead of checking every pair, we'll start with two lines that are farthest apart. So one pointer starts at the left and one starts at the right. Our left height is 1 and our right height is 6. The width is 7. The shorter height is 1, so the area is 7 cross 1, which is 7. And that's our current maximum. Now comes the entire trick. Which pointer should we move? The answer is the shorter one. Here the left line is shorter, so we move the left pointer. And there is a very important reason for this. Suppose instead I move the right pointer while keeping the height minus 1 line, the width becomes smaller and the maximum possible height is still limited by that height minus 1 line. So I have made the container narrower without giving myself any chance of increasing the limiting height. So keeping the shorter line is completely pointless. We have to move the shorter line and hope that we find a taller one. That's the key two pointers inside. So we move the left pointer. Now the left height is 7 and the right height is 6. The width is now 6 and the shorter height is 6. So our area is 6 cross 6, that equals 36. We have already beaten our previous maximum of 7. Now the right side is shorter, so we move the right pointer. We keep repeating the same rule, compare the two heights, calculate the area and move the pointer at the shorter line. We continue until the two pointers meet. The maximum we found is 36. So the algorithm is very simple. Start from both the ends, calculate the current area. If the left line is shorter, move the left, otherwise move right. Keep track of the maximum area. So now we can start solving the problem. We'll be having two pointers, left and right, and left will be pointing to the index 0 and right points to len of height minus 1. That is the last index. And I'm having a variable called max area, which initially holds the value 0, and I'm having a while loop. While left is less than right, now I have to calculate the width. Width is nothing but the right minus the left. And now to calculate the shortest height, I'm doing minimum of heights of L, or otherwise heights of right. And now I have the height and width, so I can calculate the max area, which is nothing but the maximum value of width star height, or otherwise the max area itself. And now to update the pointers, if height of left, if it is less than height of right, then I just have to increment the left pointer, or otherwise decrement the right pointer, and this must work. Return max area. Let's see. Oops, it's hide all over here. And yes, perfect. Cool, it worked. The entire trick comes down to one sentence. The shorter line limits the water, so move the shorter line. That's how we reduce the brute force Orphean square solution to Orphean. And that's GIP 9. Don't memorize DSA, recognize it.